cast. So we are having this question on practical physics, and this GCE question. This is an example of alternative to practical. You don't have to enter the lab to perform any practical. So I'll be checking 3 examples today. So let's look at this. For example, this is a question. The diagram is just given, and the first thing you have to do when you see this type of question is that you have to read and understand it properly, so that you can know how to answer the question and understand everything. Now, this is like a platform, and this is something like a pendulum with a thread. And if you look at it very well, we have the inextensible string. Okay, that's like a string. This is a bulb, and from here to here we have height of the bulb to the other level here. So for us to know how to perform experiment on this, you can see they say the diagram above shows a simple pendulum suspended with a distance h. That's the distance from the floor. Okay, the center of the bulb is at a distance h, small letter h, from here to here. That's where we should take the measurement normally, either from the floor or anything. So the bulb is set on oscillation, and the time t for 20 oscillation is taken and recorded. That has been done for us. Now the procedure is repeated 4 more times by varying h. That is, they are varying this 4 more times and obtaining the corresponding value of t. So that is the time taken using the stopwatch. So figure A and figure B shows the value of h and t. We will later check those figures now, but let's finish this respectively, where I will be 1, 2, 3, 4, and 5. Determine the what? Determine and record the real value of hi and the corresponding value of t. In each case, calculate the period t of the oscillation and evaluate t squared. Okay, so tabulate your reading. So let's do that first before we come back and go to. So we have been told to plot the graph, but for this video I will not be talking about the plotting of graph. I want to explain 3 or 4 different types of experiments in alternative physics, how we can do it. Now, checking through that, how do we do that? Let's see, this is the diagram given to us. So we have to take measurement. Everything we have to do here is to take measurement to get our first h1 means the first one, h2 means the second one, and h3. That's how it goes. So we have to tabulate, as they've said. How do we tabulate? We go to our readings. They said I. So we intentionally put I at one of the readings. So we put it this way, we say I. So our I will be 1. 1, 2, 3, 4, and 5, because they are just 5 like that. So 1, 2, 3, 4, and 5. So from there, we have to measure this, and the measurement will be done by using ruler. Mind you, look at what they put there. They said 1 centimeter. 1 centimeter represents 0.200 meters. So it means we are going to have a column for this separately. We convert to have another column, but first and foremost we have to measure. So this is a ruler, we have to measure in centimeter. So if we have to measure, so what do we have here? If you look at it properly, when we are measuring, it's from 0. So this is, looking at it, because this is 0, this should be 0.1, 2, 3, 4, 5, 6, 7, 8. So 0.8. This is 0.8 centimeter. That's the first one. From here to here is 0.8 centimeter. So we have to put it as h. So we come to the table here. The first one we said h in centimeter. So what do we get in that manner? We get 0.8. 0.8. So you can put 0 at the back, 0.80. So we come back again. We do for the second one. So the second one is around 1.5. So we come here, we write it like that, we write 1.50. Okay, we go to the third one again. So the third one, which is H3 from here, so that should be 3.1. So we go down, we write 3.1. So we write 3.1 here, 3.10. We come to number 4 again. So the fourth H now, if you look at it properly, the fourth H, so it's around 4. It's also around 4, almost 4 here. So we come here, we now write 4.00. 4.00. So the last one now, let's check the last one, which is our H5. Putting it there is around 4.567, 4.7. So we put 4.7 here, so 4.70. So we have 4.70 over there. So that's for H. So the next thing we have to do, we have to convert. Because we have some conversion here. Look at it. 1 centimeter represents 0.200. How do we do that? It's very simple. So we have to write the conversion down. That is 1 centimeter represents 0.200 meters. So we'll be taking them one after the other. I've written it down here. So we take them one after the other. So the first one, 0.80. So 0.80 centimeter, we have to write it here. It means 0.80 centimeter. We now represent, what do? We cross multiply. So this multiplies this. We divide it by this. So it means we have 0.80 times 0.2. Okay? 0.80 times 0.2. So it means we have 0.8 times 0.2. So we have 0.16. So there we put 0.16. So here now we are going to have another column, which will be our original H. So we put it as 8, our original H. Mind you, the unit is meters. So we have to put there as meters now. So we put there as meters. Okay? When we calculated, we got 0.16. Mind you, you must put another 0. Because whenever you have multiplied or divided, try to make it 3 decimal place. Or since we are multiplying, so let's try to make it that way. So let's go on again. This one is 1.5. So we have to be multiplying everything by 0.2 now. Everything by 0.2. So this is 1.5. We multiply by 0.2. What do we get? So 1.5 times 0.2. So that gives us 0.3. So we have to put 0.3. So you can put 0.30. You can put it in 3 decimal place. We can leave it at 2 decimal place like that, since we are not dividing. So we put 3 again. So 3.1 times 0.2. So that gives us 0.62. So we have 0.62 here. So we multiply again. It goes like that. 4 times 0.2. Okay. So we have 0.8. So it goes like that. So 4.7 times 0.2. So we have 0.94. That column is done. So we have to get another column. Now, they gave us this diagram. Because I told you it's alternative to practical, so we don't need to perform any practical. What we have to do is just to check it. Look at this. This is the first time, T1. This first time, what do? We look at it critically. This 0, from 0 it comes down here, is 15. So it means between here and here we have 2 things. It means this one will be 0. If this one is 5, so this one will be 10. This will be 15. Okay? Difference of 5, 20, 25, 30, 35, 40, 45, 50. So 50 is now being divided. Between 50 and 55, I think we divide into 5. So 50, 51, 52, 53, 54, and 55. So between this 50, 51, 52, 53, between 53 and 54, that's where this thing is. So it means it is 53.5. It means it is 53.5. That's our T1. So we now go to the table. We now put our T, okay, in seconds. T in seconds. So we put 53.50. Because it's 53.5.50. That's the first one. Mind you, it's under 1 because it's T1. Let's go for the one under 2. So we check it here. So what do you have here? You have T2. T2 here will be, this is 50, this should be 51. So it's between 50 and 51. That should be 50.5. So we have 50.50. So we write it 50.50. 50.50. We come again to check through it. So we have the T3. T3 you can see is here. So this is 40, 41, 42, 43. Between 43 and 44, that is 43.5. So here we have our 43.5. So we write it 43.50. So we have for T4 now. So this is our T4. So it's on 40. It's on 40. That's 40.00. So we have 40.00. Now, the number 5, the fifth one, which is this, 35. Between 35 and 35 and 36. So we have 35.5. So we write it here as 35.5. So we have 35.50. Okay. What's the next thing we have to do? This one is direct. We don't have to change anything. But they told us from the question. Let's look at the question again. They told us from the question that calculate the period T of oscillation. And how many oscillations do you have? We have 20 oscillations. How do we do that? Remember that our period will be equal to T over number of oscillation. That's T over N. So it means we are going to divide this one by 20. Everything here by 20. Another column here. Mind you, is the same unit, which is seconds. So we will be dividing everything by 20, since our number of oscillation is 20. So and everything here is our T. So we now say 53.5 divided by 20. So 53.5 divided by 20. Okay, you are not seeing the question. Oh, sorry. So this is what I will do. Let me go through the question again, please. We have 2.675. So 2.675. Let me go through the question again, please. So let's look at the question. I've read the question in the beginning of the video, but some people say they are not seeing it. Now, look at it here. They gave us the diagram, okay? But the question says the diagram above shows a simple pendulum suspended. That's what I have there. So that's the question. Okay. So what I will do is this, please. On the comment section below, once I upload this video, I will screenshot the question and I will send it. So I will attach it down. I will attach it under the comment section of this video after it has been uploaded. Maybe tomorrow, please, you can come back and check. And you will see the question there, live and direct, so that you can do it by yourself. And you see how it is being done. Okay? So let's go on, please. So everything here, we have to divide by 20. We have to divide everything by 20. So what do we do? So we have done this, divided by 20. So we also say, mind you, it will be 3 decimal places. We also say 50.5 divided by 20. So that gives us 2.525. So we have 2.525. So that's how we do that one. I don't want to be wasting our time, so we do the same thing down like that. So let's go to another information again. They now told us that once you have gotten the period, okay, once you have what? Gotten the period, you can see the procedure is repeated, blah, blah, blah. They now say the period of T and evaluate T square. Evaluate T square. What is T square? You still have to square it. Just follow everything. They will be giving you mark for everything. This one, mark, another mark, just like that. It's very, very simple. Alternative to practical physics is very simple. So our T square, it means it will be second square. So you now be squaring this again. Square this, put it here. Square this, put it there. So at the end of the day, you'll be told to tabulate this original H in meters against this. So next time I will do video on how you can do scaling You scale your graph. I've even made a video on it, I think. Yes, if you check my channel, the video on it how you can scale graph properly. So they will say you should do this against this, because the instructions say plot a graph of t square on the vertical axis and the real value of h, and that real value is the one we have converted here, which is now meters. That's the real value. You do that against them, and that's that about that. That's one example of alternative to practical physics in GCE. Let's look at another example, please. Look at this. This one is on light. The other one we did the other time is on mechanics. This is light. This question on light. If you look at it very well, you can see that we have object here, and we have our lens, okay, and we have the screen to observe what is being trapped. So from here to here is u, okay, and you know that u is the what? Is the distance moved by the what? By the object most of the time. Look at this one is x. So in the experiment setup shown above, an illuminated object O is placed at a distance u. You can see that's the distance of the object, as I said, from the lens. The position of the screen is adjusted to obtain a sharply focused image I of the object on the screen. They say the position is being adjusted. So the distance u and that between the object and the image are measured and recorded. The procedure is repeated 4 more times by varying u. So this one is being varied, okay, and obtaining the corresponding value of x, that is this. Once this one is varied, we get that. So figure 2 shows the position of the object. We soon look at the figure and see how they put it there, and the corresponding position of the image, okay. This is the corresponding position of the image, which is L, where I is 1 2 3 4 5. So we are going to have another high 1 2 3 4 5. So what do we do now? Measure and record the real distance u of the object. So let's go to that thing first. Let's see what they are giving to us, and let's see the diagram. Yeah, this is the diagram. You can see this is the diagram giving us different position. This is O1. So O1 will be related to I1. O1 and I1 will be related. So if you want to calculate your u, mind you, your u is between here and here. Don't forget. And your x is between here and here now, just from the diagram. If you look at this very, very well. Because if you go back to the diagram, you see that our u is between object and the lens, okay? And our x is between the object and the screen. So for each scenario, they gave us the diagram here. So for everything here, this one is between, now O1 is between the first object is here, the screen is the lens is here, and the first screen is here. So if you have been told, and they told us the scale is 1 centimeter representing 10 centimeter. Anything we get first will be 1 centimeter. Okay, we now go for the real. We multiply by 10 to get the real. So what do we now do? We also make a table for that, and it is from the table that we have to do our calculation. So making the table now, we have to measure from here to here, because they say we should get our u. Our u is in centimeter, and our x is also in centimeter. So let's make a table for u. So here now, the first thing we have to do is to say our I is 1 2 3 4 and 5. So we make a table for u in centimeter, which is measured. So you can put it on top and just write measured. So the real will be the real later. So let's do that first. So measured, we have to take our ruler, as we have always done, in centimeters. So we have to place our ruler and get in between O, Y, and this. That's 2. 2 on the dot. I can see it. It's 2 on the dot. So we now write it as 2.00. 2.00. So now we go for the second one, which is u also. So the second u will be from O2 there. So I put my ruler there, O2. Now that's 2.5. 2.5. So I write it as 2.50. Now the third one, which is this. So I place it on the third one here, and that's 3. That's 3 on the dot. 3. Don't let me do more than that so that I will not waste your time, because after this I still want us to get another column. So the other column now, U in centimeters, that will now be real. You make it real, okay? So that real, mind you, they gave us 1 centimeter represent 10, so you have to multiply by 10. Therefore, anything you want to write, you put it here, represent, cross multiply. So it will be 10 now, okay? You have to multiply everything by 10. So 2 will become 20. So this will now be 20.0. This one multiplied by 10, that will be 25.0. Okay, so this one will be, that will be 30.0. Okay, you need my WhatsApp number. Okay, Ebu CJ, I will send my WhatsApp number. Please, after this, try to come to my channel. Please send your message and ask for my WhatsApp number under any of my videos, because possibly I might not get this message again after the live telecast. Are you getting me now? Please just try as much as possible to, okay, let me pin your message. I've pinned it. So possibly I might get so I will send you my WhatsApp to join my inner group so that I can teach you more of the physics. There's no problem. I will send my WhatsApp number to you. Now, so this multiplied by 10. So now we are told to find x also. It's not hard at all. To find x, remember that x is the distance between the object and the screen. So for O1 to high 1, O2 to high 2, that's how we get our x. So getting our x, O1 to, so we have to put it there like this. So our the first one, that's 8. I can see 8 there. 8, that's 8. So that one will now be 8, and that's our x. So you have to write x in centimeter. Okay, this one is measured. Is what? Measured. So taking that measured, under the measured, you have to write 8, because I got 8. So 8.00. Mind you, this one also we have to get our x centimeter for real. And the real one is when you have converted, as you've said, that is to 10. So you have to multiply by 10. So this 8 becomes 80.00. Okay, it becomes 80.00. And it is from there that you measure this also, measure this, measure this, measure this. And from the instruction, we get to know that they told us that measure, you can see, measure and record the real distance u of the object from the lens and the corresponding real distance x between the object and the image position. That we have done. Tabulate your readings. You have done that. You have tabulated it. Okay. Then now say plot a graph of x on the vertical axis and u on the horizontal axis. You can see our x that is real, okay, against our u that is real. Are you getting it? This on the vertical, this on the horizontal. As I've told you, I've made video on how you can scale, and I can also make a live video on it if you really wanted it. So that's one method under this okay. After that, we now plot our graph and we do other calculations on it. So let's check another one. This one is now electricity. Let's check this method on electricity. So GCE will bring things like this, and they will explain as normal, as they've always done. They will explain, and when they are explaining, they will still give us diagram, and everything is always measurement. I've told you, everything is always measurement. It's always measurement. So that is the third one, and we go to another one, which is the fourth one, and I will stop after the first one. Okay, after the fourth one, sorry. So let's go on. This also gave us the setup. Okay, this is the rheostat, this is the cell, the key, this is the ammeter, and this is the voltmeter that we can check potential difference between one end and another end of a resistor. Ammeter is the one that will be in series. Both of them are there. So an electrical circuit is collected as shown in the above. The key is closed and the rheostat adjusted such that a small current passes in the circuit. The current I in the circuit, okay, and the potential difference V across the 2 meter. You can see potential difference. Yes. Resistor are read from the ammeter and the voltmeter respectively, both of them are reading it. Okay, the procedure is repeated 4 more times, that is, everything is 5 times like normal, by adjusting the rheostat each to obtain higher value of the current. The potential difference, now they gave us a figure also, shows the value of the current. This is corresponding value of the potential difference. So we have to find value of potential difference, VI, where our high is 1 to 5. So we do normally as we always do, which is not something hard. So we have to go for our high, and our high is what we do first. So our high now is 1, 2, 3, 4, and 5 as normal. Okay, once we have done that, what's the next thing that we have to do? We are being told to find from figure A and figure B. Let's look at our figure A and figure B, and let's see what we have there. Now look at our figure. This is figure A. You are not using any ruler here because that's electricity for you. We just have to be able to read what is here. This is figure B. You have to be able to read. Figure A is the voltmeter reading in volts, and figure B is the what? Is the ammeter reading in what? Ampere. So that's what we have to do. So we have to go to our table and we have to do like this. Let me put it. We have our V, which is in volts. So let's take the readings. The first one, which is V1, under 1. V1, look at it very well. We have to know the scaling very first. We have to know what is happening here. Please like this video in order to encourage us to do more. I'm here to help you, whether you're in SS1, SS2, SS3, I mean grade 11, grade 10, grade 11, and grade 12. You're expecting your exam. I can help you on anything. So as we have it here, we have to get the scale first. From here to here is 0.5. So that's 0.5. Let's divide it into 1, 2, 3, 4, 5. When you divide 0.5 into 5, what will it give to you? You can use your calculator if it's giving you a problem. So 0.5, okay, divided by 5. So we have 0.1. That's just it. So it means everything here is represented by 0.1. So this is 0.1. This one will be 0.2, 0.3, 0.4, 0.5. That's very easy. So let's look at our V1. This is our V1 here. Is on 0.1, 0.2. So we have to write it here as 0.2. So you can put 0.2 and put 0 at the back just to make it easy. Look at this now. The second one, which is V2, is on 0.5, 0.6. So what do you have to do? Very simple. It's very, very simple. 0.6. Alternative to practical. Very, very simple. So that's 0.6. Looking here now, V3 now, look at it. This is 1.0, 1.1, 1.2, 1.3, 1.4. Very simple thing. So you put 1.4 like that. You just have to be very careful when you are doing it. That's just it. The next thing is just the graphing, and we do that also very soon. So 4 now, V4. This is 1.5, 1.6, 1.7. It's between 1.7 and 1.8. So that would be 1.75. 1.75. So you have to write it as 1.75. Okay. So number 5, which is V5, 2.0, 2.1, 2.2, 2.3, and 2.4. So this one is 2.4. So you have 2.40. You can see it over there. So from the question now, the next thing that they gave us the diagram is the ammeter, and that one will always be in what? In ampere. That's the ammeter. So checking through the ammeter now, the ammeter is in ampere. So you have to write in the table as ammeter, which is A, okay, and that's the current. Okay, that's the current. So anything that is here is what you have to write first. I. So we use I to represent that. Sorry, that's the current. I made a mistake over there. So I here. Now what's the unit? Ampere, which is A. So look at the first one. Let's check. It's just like the other one here. Very simple. So this is 0.1 now. So I1 is on 0.1. So we have 0.1 here. So 0.10. Okay. Our I2 now. I2 is on 0.1, 0.2, 0.3. So I2 is on 0.3. So we move over there now, we have 0.3 on height 2 over there. So let's go to number 3 now, the third one. So the third one here, 0.5, 0.6, 0.7. That's the third one. Okay, so we come here, we put 0.7. I won't waste your time. So let's leave it like that. So this one, electricity, there are just two things. And if you look at it, they will tell us to plot the graph. Let's look at it. After saying all this, read and record the value of I. We have done that. And the corresponding value of V. We have to evaluate, okay, V raised to power minus 1 and I raised to power what? Minus 1. That's the inverse of them. So we have to do that also. So we have V raised to power minus 1. The unit will always be ampere raised to power minus 1 also. How do we do this? V raised to power minus 1 means 1 over V. So anything you get here, you say 1 over that. That's how you do it. 1 over this, you put it here. 1 over this, you put it here. So 1 over 0.20 now. 1 over 0.20. So 1 divided by 0.20. So we have 5. Ha. So it means this place we have 5. That will now be 5.00. I think that 20 is good. We can put 3 zeros because we are dividing. We are dividing, please. So you do that to this one also. Okay. 1 divided by 0.6. So 1 divided by 0.6. So that gives us 1.666. So we have to write it as 1.667. So this one is 1.4. So we have to say 1 divided by 1.40. So 1 divided by 1.4. So this gives us 0 point something. That's why you have it there. So I press fix 9. So that should be 0.714. So 0.714. Okay. So you go to the second one also because they told us also to find I inverse. So we have to go there. We just follow the instruction. Very simple thing. Just make sure you don't make mistake. So this one, oh, I made a mistake here. I'm very sorry, please. This should be in volts also. Volts raised to power minus 1. Okay. Volt raised to power minus 1. That is volt raised to power minus 1. So this one will be ampere raised to power minus 1. Okay. So we don't approximate this one to 1.67, please. Let it be in 3 decimal places. When you divide, let it always be in 3 decimal places. Okay. Don't put it in 2. This one that you measured, anything measured directly is 2 decimal. But anything you divide, let it be in 3 decimal places. So this one also, you do it the same way. You divide it divide by this, 1 divided by this, you write it here. And that's all to cater for that. So let us check one other one. And let's just check one other one. And we call it a day. Let us check one other one. Look at this, for example. This is another experimental setup. Okay, which is talking about what? The internal diameter D of an empty beaker is measured. Okay, you can see this now. They are measuring the internal diameter from here to here. You can see that's D there. Okay, and they are talking about the mass, different masses that is suspended. And they gave us everything, blah, blah, blah here. Okay, so we read that intensively. And I'm particularly about this. These are the things to be taken. You can see the first mass is M1 here. Because they took also 1, 2, 3, 4, 5. So the same way, we are going to have our I1 to I5. So let me manage this place. So we still have our I again. So it means we are going to have our I to be 1, 2, 3, 4, and what? And 5. Just as normal. So when you want to take this is the mass. So you write it as M. So I'm coming here because this one is very trickish. This is where I'm coming. If you see any broken thing like this, never you make a mistake that will cost you problem. Don't measure from 0, please. Don't think you are measuring from 0 here and going up. Never do that. Never and never do that. Look at here. they put 2.8 centimeters. This is where you should start measuring from, please and please. So you are going to have 2.8 centimeters to everything. I think I have to say that now. This is our D that they use in that place. Okay, if you look at that diagram very well, you see that there's a particular diagram where they put, look at it, you can see D. This from here to here. So you have to be very careful, please. And they are giving you this, and they intentionally broke it here. Ignorantly, people will start taking from 0 to D0, yeah? From 0 to D1, 0 to D2. Never you do that. Please and please. You have to take from here to here for D0. And D0 is something constant that we are going to use later. From here to here for D1. From here to here for D2. And anytime you take from here to here for D1, you have to add 2.8 because you started from 2.8. Mind you, and that's what you put in your table, in your form. And I believe you can do that by yourself now. Look at this. This is 100. You count the number of things that are broken, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you divide 100 by 10. That will be 10. So every line means 10. So this is 10, 20, 30, 40, 50. So here is 50 gram now because they told us it's gram. 50 gram. That's what we are going to record. You record it as 50.00. This one will be 100. That's M2. M3 will be what? Between 100, you have to put 10. 110, 120, 130, 140, 150. So you have to put 150. So the other one is what? 200. It's very simple. The other one is 250. It follows like that. But this place is somehow trickish. Very, very tricky. And you can see they put another measurement here. This D is the singular D that we'll be using. From the instruction you will see, they will tell you what to do with it. No two questions is always the same. No two questions are always the same. Just follow the instruction, read it very well, and see what you have to measure or what you have to do. That's how alternative physics always go in terms of GCE. Please mind you and put it in your brain. Now, see you next time. We always have on Wednesdays and Sundays, we always have a session like this, which is live. So I can make some videos that are not live and send it to you people. Thank you. God bless you. See you next time. Thank you.